This video is dedicated to the great Indian genius and mathematician Srinivasa Ramanujan, whose sublime mathematics is still today a source of great inspiration for me and for many other researchers. In this video we analyze some formulas regarding various Ramanujan series for estimating the value of pi. These expressions are taken from Srinivasa Ramanujan's seminal work, Modular Equations and Approximations to pi. We describe some new possible mathematical connection with Ramanujan's recurring numbers, the Dn constant, and some parameters of string theory. Let us remember that by Ramanujan's recurring numbers, we mean the following numbers: 1729, 4096, pi squared over 6, that is equal to zeta 2, and the golden ratio, phi. We analyze the following formula. We obtain the following expression and the following result, that in decimal approximation is equal to pi. Step by step we list the various properties of the expressions analyzed above. Property, alternate forms, expanded logarithmic form, reduced logarithmic form, alternative representation, series representation, integral representation. Now, from the following approximation, we obtain the following expression and the following result, that in decimal approximation is equal about to pi. Also here, step by step, we list the various properties of the expression analyzed. Alternate forms, the property that this expression is equal to a transcendental number, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, and the integral representation. From the following approximation, we obtain the following expressions and the following result. Again, a value practically equal to pi. Also here, step by step, we list the various properties of the expression analyzed. The properties that the formula is give a result that is a transcendental number, the alternate forms, the reduced logarithmic form, the alternative representation, the series representations, the integral representation. From the following approximation, we consider we obtain the following expression and the following result, that in decimal approximation is equal, is a very good approximation to pi. Also here, step by step, we list the various properties of the expression analyzed. Alternate forms, expanded logarithmic form, and so on. Integral representation. Now, from the following approximation, we consider the following expressions and obtain the following result, that in decimal approximation is equal is a very good approximation to pi. Also here we list the various properties: transcendental number, alternative forms, expanded logarithmic forms, alternative representations. Now, multiplying the first two results, alternative forms, we obtain the following expression, the following result, that in decimal approximation is equal to pi squared. Okay. Is equal about to pi squared. Step by step we list the various properties of the expression analyzed, choose the alternate forms, reduce the logarithmic forms, alternative representations, series representations, integral representation. Multiplying the other two results, alternative forms, we obtain the following expressions, and the following result, that in decimal approximation is about equal to pi squared, as above. Also here, step by step, we list the various properties of the expression analyzed, choose the alternate forms, the reduced logarithmic form, the alternative representations, the series representations, the integral representation. From the following last approximation, we obtain the following expressions and the following result, that in decimal approximation is a very good approximation to pi, practically is equal to pi. Also here, step by step, we list the various properties of the expression analyzed, choose the alternate forms, the expanded form. Now, multiplying the two previous results, alternate forms 1 and 2, we obtain the following expressions and the following result, that is equal to pi raised to fourth power. Pi raised to the fourth power. Also here, step by step, we list the various properties of the expression analyzed, choose the alternate forms, the alternative representations, multiplying the previous result from the last alternative forms, that is the following, we obtain the previous result from the last alternative forms, that is the following, we obtain these expressions and the following results. That is equal to pi raised to the fifth power. Okay, pi raised to the fifth power. Step by step, we list the various properties of the expression analyzed. Then choose the expanded logarithmic form, the alternative representations, the series representations, and the integral representation. From the previous expression, after some calculation, practically this expression, we note that 13 is a Fibonacci number, 123 and 7 are Lucas number, and phi is the golden ratio. We have the following expression and the following result. About equal to 4096 that multiplied by 2 gave 8192. The gauge group SO 8192 is fundamental for the open bosonic string theory. From the above expression, we obtain also the following expression, practically performing the square root of the previous expressions plus 1 and multiply all the expression for 27. We obtain this expression and the following result. Result that is very near to the mass of candidate global F0 1710 scalar meson. Furthermore, we know that 1729 is the Hardy Ramanujan number, that is a taxicab number, as it can be expressed as the sum of two cubes in two different ways. And it is also a Ramanujan recurring number. Also here we have the expanded logarithmic form. And again, performing the 15th root, to which we add this regularizer containing the Marvin-Rayburn constant, we obtain the following expression. And the following results. That is equal to p squared over 6, practically zeta 2. And again, from the following formula, we obtain from the previous expression the following new expressions. We obtain as results practically the value of the n constant, that is 2 root of 2 over pi, 2 root of 2 over pi, the value of the n constant. Now, from the sum of the previous two expressions, we obtain the following expressions and the following results, practically 2 times pi equal to the value of a circle of unit radius. Choose from the sum of the previous two expressions, we obtain this expression and these results, 2 times pi, that is equal to the value of a circle of unit radius. Also here, step by step, we list the various properties of the expression analyzed, choose the alternate forms, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, the integral representation. From the sum of the other two previous expressions, we obtain the following expression and the following results, practically 2 times pi as above. Also here, alternate forms, expanded logarithmic form, reduced logarithmic form, alternative representation, series representation, and integral representations. And from the last expression we obtain the following expressions and the following results. Practically, result that in decimal approximation is equal to pi. Results that in decimal approximation is equal to pi. Also here, step by step, we list the various properties of the expressions. Practically the alternate forms, the expanded form, the alternative representations. In conclusion, we obtain the following final expressions that and the result is a very good approximation to the values of 5 times pi. We note that by adding only the first two results, practically 2 times pi plus 2 times pi, we obtain 4 times pi, which is equal to the semiclassical entropy for M equal to 3, L0 equal to 1, and D degenerates equal to the value that is the less number of dimensions in which the mass and group can act non-trivially. Also here we obtain the alternate forms, the expanded form, the reduced logarithmic form. Furthermore, from the previous result, we obtain also, after following AC calculation, these expressions, where 89, 21, and 2 are Fibonacci numbers, while gamma is the Euler-Mascheroni constant, and the result is the following number. Decimal result. This is very near to the mass of candidate gluable, F0 1710, scalar Mason. Furthermore, 1729 is the so-called Hardy-Ramanujan number. From the above expression, performing the 15th root and adding the regularizer containing the Marvin-Rayburn constant, we obtain the following expression and the following results. Practically p squared over 6, that is equal to zeta 2, Now, from the expression that gives 1729, subtracting 1, dividing by 27, and squaring everything, we get the following expressions and the following results. Results very near to the value for 2096, that is a Ramanujan recurring number that multiplied by 2 gave 8192. That is fundamental from the open bosonic string theory, and this is the gauge group SO 8192. Now, on the application of the formulas of the volumes of an octahedron and a sphere. With regard to the volume of an octahedron and of a sphere, we have the following formulas: 1 and 2, where the radius is equal to Rs equal to 1 over 2, 1 over 2. With regard to the ratio between the two above formulas, octahedron and sphere, we obtain the following expression and the following result. Result practically 2 root of 2 over pi, that is the n constant. Also here, step by step, we list the various properties of the expression analyzed. 2 root of 2 over pi is a transcendental number. Also here we obtain series representations. From the previous expression, performing the following calculation, we obtain the following result. Practically, we obtain pi squared over 6. Pi squared over 6. That is equal to zeta 2. Also here we list the various properties of the expression analyzed. Pi squared over 6 is a transcendental number. Also here we obtain the series representations and the integral representations. We note that from the sum of the first 9 numbers, excluding 0, we obtain the following interesting formula. This is the expression, and this is the exact result, that in decimal approximation is equal to a value very near to pi squared over 6, practically zeta 2. Also here we list the various properties of the expression analyzed, choose the alternate forms, the expanded forms, and from the following formula, practically taking the square root of the previous expressions, which gives the value of pi squared over 6, we obtain the following expression and the following exact result, that in decimal approximation is equal to a good approximation to pi, that is a Ramanujan recurring number. Also here we list the various properties of the expression analyzed, choose the alternate forms, the expanded forms. Furthermore, we obtain also from the following calculation, practically from the ratio between the two volumes, multiply for 2 times pi by square root of 2, we obtain from as exact result 8, value that is linked to the Ramanujan function that has 8 modes corresponding to the physical vibration of a superstring. Also here we list the various properties of the expression analyzed, choose the series representations, and also from the following calculation, 6 times pi multiplied by square root of 2 multiplied by the ratio between the two volumes, we obtain as exact result 24. 24 and value that is linked to the Ramanujan function that has 24 modes corresponding to the physical vibration of a bosonic string. Also here we list the various properties of the expression analyzed. Choose the series representations. From the previous expression, which gives 8, raising everything to the 4th power, we obtain the expression raising to the 4th power, we obtain 4096. that is a Ramanujan recurring number. As previously, after the following calculation, we obtain from the previous formula 1729, that is the Hardy-Ramanujan number, and we list the various properties of the expression analyzed. Also here the series representations. We note that from the sum of the two expressions that give 1729 and 4096, after some simple calculation, we obtain the following expression and the following exact results. Practically a result that is a very good approximation to the value of the golden ratio, that is a Ramanujan recurring number. Furthermore, we note that 233 and 144 are two Fibonacci numbers, and that their ratio, as for all the numbers of the Fibonacci series, tends to the golden ratio. Also here we list the various properties of the expression analyzed. Choose the series representations. Now, from the dn constant, practically 2 root of 2 over pi, 2 root of 2 over pi, that is a transcendental number, we obtain also from this formula pi. This formula from the dn constant, we obtain practically pi. We list the various properties of the expression analyzed. Pi, that is a transcendental number, the roots, the series representations, the integral representations. Now, from pi squared over 6, we obtain by the following formula, okay? Again, the dn constant, practically 2 root of 2 over pi, 2 root of 2 over pi, practically again the dn constant. We list the various properties of the expression analyzed. 2 root of 2 over pi is a transcendental number. This is the roots, the series representations. Then, from what is described in this video, we notice from pi we obtain pi squared over 6, which is also the value of zeta2, the dn constant, from which we obtain 8 and 24, numbers linked to the physical vibration of superstrings and bosonic strings respectively. We obtain 1729 and 4096, from the sum of which, after some simple calculation, the golden ratio is obtained. It is plausible to hypothesize that pi and phi, the golden ratio, in addition to being important mathematical constants, are constants that also have a fundamental relevance in the various sectors of theoretical physics and cosmology. When Ramanujan wrote the seminal work Modular Equations and Approximations to Pi, did he think about what important developments he would make? Was he thinking about the connection with some parameters of the strings such as physical vibration, to the connection of pi with the entropy of a black hole? We believe that Srinivasa Ramanujan certainly understood the importance of his work and the future and the incredible consequences that this sublime and elegant mathematics will provide and still provide. Thank you very much for the attention.